Welcome to Electricity, Hazards, Risks, and Precautions training. In this training, participants will gain knowledge about electricity, hazards, risks, and precautions. By the end of this training, participants will be able to acknowledge electricity, the hazards associated with electricity, damage caused by electrical accidents, precautions to be taken, and how to respond to electrical accidents. The amount of electric charge electrons passing through a conductor or receiver per unit time is called current. Current arises from the movement of electrons. When an electric field is applied to conductive materials, electrons move from the negative to the positive direction. This movement is called electric current. Its unit is the ampere. Currents are divided into two types: direct current DC and alternating current AC. Direct current is the current whose direction and intensity do not change over time. Current whose direction and intensity change over time is called alternating current. Alternating current is used in large electrical circuits and high-power electric motors. The electricity in our homes falls under the category of alternating current. Refrigerators, washing machines, dishwashers, exhaust fans, and ventilators operate directly on alternating current. Devices such as televisions, stereo systems, and video players, however, convert this alternating current into direct current for use. Electric shock is a hazard caused by electricity. Could happen by direct contact with an electrified point, direct contact, or happen by touching a point where there should be no electricity but there is indirect contact. Factors affecting the effects of electric current on the body are intensity of the electric current, voltage at the point of contact, electrical body resistance, duration of exposure to electric current, path of the electric current through the body. Electrical accidents could damage the employee as non-fatal minor electric shock, electrical shock resulting in death, or burns. Some damages could occur at the workplace as fire, explosion, or damage to machinery and various equipment. Physical effects: burns, effects on muscles, effects on the heart, effects on the nervous system are the effects of electric shock. Since electric current passing through living bodies causes burns and muscle cramps, the person involved in the accident cannot release the object that is in contact with the electricity. Due to the higher intensity of the electric field applied to the body at high voltages, many organs outside the circulatory system also become conductive. In particular, the excessive heat generated due to the resistance effect of the skin tissue located along the conduction path causes tissue burns. If this path of electric current leads from hand to foot, heart, liver, and kidney are damaged. If this path leads from one hand to another, the heart and the lungs are damaged. If this path leads from head to toe, brain, heart, lungs, and kidney might have serious damage. Effects of low voltage alternating current can be counted as suffocation due to paralysis of the diaphragm, cardiac arrest. Effects of high voltage alternating current can be counted as cardiac arrest and internal burns. Effects of direct current can be counted as burning of blood and subsequent molecular breakdown due to electrolysis. Here are the causes of electrical accidents: lack of knowledge, insulation-related problems, overconfidence and risk-taking by employees, rushing, carelessness, and lack of attention, failure to follow work discipline/rules, failure to use personal protective equipment, failure to conduct periodic inspections, inadequate grounding of metal parts of equipment, working with high voltage when not necessary, interfering with malfunctions without instructions. Here are the precautions to be taken against direct contact. 1. Stay away from frayed cables and report any irregularities to the operator. 2. Access to hazardous areas must be prevented. 3. Exposed cables must be isolated by a qualified electrician. Here are the precautions to be taken against indirect contact. 1. Body grounding. 2. Ground fault circuit interrupter. 3. Use of protective hand tools. Earth leakage circuit breaker is a protective device that operates based on the principle that the currents entering and exiting an electrical circuit must be equal. In other words, if current flows through the human body, a difference will occur between the incoming and outgoing currents, causing the electrical circuit to be interrupted. Insulating hand tools and devices that are not normally under voltage but may become electrified during use. Hand tools used in electrical work, such as pliers, needle nose pliers, side cutters, screwdrivers, and similar tools, must be properly insulated. The handles of cleaning tools such as brooms, brushes, and mops must be made of insulating material. To prevent electric shock in the event of a work or insulation fault, electrical tools must be designed to operate at voltages below 42 V. Grounding is not required for such tools. In places where there are narrow and conductive parts similar to those in boilers, in wet places, low voltage should be used if lamps operating with alternating current are used. Plugs in these circuits should be selected so that they do not fit into sockets with higher voltages that may be located in the same place. Pliers, screwdrivers, and similar hand tools used in electrical work must be properly insulated, and the handles of oil cans, brooms, brushes, and other cleaning tools must be made of non-conductive material. When working near bare conductors, wear a face-protected helmet and insulated work boots. Do not use broken or cracked plugs or sockets. Connections related to electrical machinery must be made in such a way as to withstand vibrations that may occur during operation. Non-original, repaired, or bridged fuses should not be used in electrical installations. Labels indicating the location they control should be placed on the insurance, switches, and keys on the table or panel. Portable or movable conductors should not be used continuously in workplaces. However, if they must be used temporarily for work-related reasons, necessary safety precautions must be taken. Those working with portable electric tools should not wear loose clothing and should use insulated gloves suitable for the job. Before using electric hand tools, they must be inspected by authorized personnel. Tools with faulty grounding, excessive sparking motors, damaged plugs, sockets, switches, or connection cables must not be used. When electrical hand tools are not in use, their cords should be unplugged from the outlet and stored in a safe place. Power supply and source cables must be protected in such a way that they will not be damaged or broken if a vehicle passes over them. Plugs must be designed and constructed in such a way that they cannot be inserted into sockets intended for different voltages used in the same facility. Fuses used in alternating or direct current circuits must be mounted in a closed panel. Electrical cables must be insulated in accordance with their voltage ratings, and these cables, along with their connection and control devices, must be adequately protected against external influences. Conductors must be installed in a manner that protects them from mechanical and chemical effects. Maintenance and repair work should only begin after the absence of voltage has been confirmed at the work site. Distribution boards, panels, control devices, and similar equipment must be located in areas accessible to employees and kept in locked cabinets or cells. To prevent static electricity, depending on the nature of the work, humidification, bonding, and grounding, one or more ionization methods must be applied. For humidification, by maintaining the ambient air at a humidity level that allows static electric current to pass through, static charging can be prevented. Since humidification is harmful to many materials and excessive humidity can be uncomfortable for people, the application of this method is limited. For bonding and grounding, connecting objects with static electricity properties to each other using a conductor and grounding them. This balances the static electric charge in the objects and eliminates it through the ground connection. All storage facilities and pipe equipment containing flammable and explosive liquids and gases must be grounded against static electricity using this method. During the filling or emptying of storage tanks, the grounding connection of vehicles must be ensured. For ionization methods, air is normally an insulator. However, by ionizing the air sufficiently, the buildup of static electricity on objects can be prevented. Methods such as static brushes, radioactivity, or open flames are used to ionize the air. Hard hat with CE mark must be used in hazardous areas generally. Almost every area of the facility is considered a hazardous area. Insulated gloves suitable for the voltage of the equipment or machinery being worked on must be used. Gloves with even the smallest holes or tears must not be used under any circumstances. They must be inspected before each use. After use, gloves should be placed in their designated box or bag. Face protective masks must be CE marked. The mask must protect the face against ultraviolet UV rays, particles, or other objects. In the event of an electrical accident, the first thing to do is turn off the power. If this is not possible, the person involved in the accident must be separated from the electrical source. This can be done by using insulating materials such as dry wooden planks or clothing available at the scene to intervene at the point of contact and sever the person's connection to the electrical source. Do not touch the injured person while responding to the accident. The forgetfulness factor must be taken into account. Warning signs should be placed in appropriate locations, ensuring that instructions are concise and clear, and establishing multiple safety systems. People who have learned a certain task and practiced it for a long time expect certain results from their actions. For example, for a machine switch that operates by moving up and down, it is expected that the machine will start when the switch is moved up and stop when it is moved down. However, when we look at the switches we use to turn on and off electric lights in homes or workplaces, we see that they do not adhere to this standard. Some turn the light on when the switch is in the down position, while others do so when it is in the up position. In the event of a power outage, it is impossible to determine which switch is open and which is closed, which could lead to unwanted situations when the power returns. For similar reasons, accidents related to this issue cannot be prevented in machine designs unless human habits and expectations are taken into account. People want to stand out and prove themselves. Playing with electricity, such as climbing a pole to connect the power without turning it off, repairing a machine or panel, or lighting a bulb with their mouth, is a result of these feelings. Even when employees are aware of certain risks, they may disregard these risks by prioritizing values such as masculinity, toughness, boldness, and self-confidence, or by trying to prove themselves to their employers. As long as these behaviors are rewarded instead of punished, workplace accidents will continue to occur. Excessive vibration, noise, drafts, humidity levels, and physical strain in the workplace and similar factors can cause excessive stress, which can lead to accidents by undermining motivation. Accidents may occur if protective equipment and other hand tools provided for workplace and worker safety do not conform to the user's ergonomics. For example, the size of insulated gloves must be compatible with the size of the worker's hands.